We will take a new topic, that is capacitors. First we'll see what is a capacitor. Capacitor is a system of two conductors separated by an insulator. So capacitor is a system of two conductors separated by an insulator. Now two conductors, generally one charge positive and the other will be minus. Conductors are by some distance. To conduct Q2, two conductors will have Q1 is plus minus. Let the electric potential is V1 and in the second conductor it is V2. So there will be a potential difference between these two conductors. The potential difference is given by V is V1 minus V2. So this is the general arrangement of a capacitor. It will have two conductors separated by a dielectric. So here is the air. Air is a dielectric, or I can say it as an insulator. One conductor has a potential V1, other one has V2. So they will have a potential difference of V1 minus V2. Now by definition we know the potential difference V is the work done per unit positive charge. The potential difference, what is the potential difference? We have studied the definition. Potential difference is the work done per unit positive charge. Work done per unit positive charge in taking test charge, taking charge from 2 to 1. From 2 to 1. We take minus V2. Again. Therefore, V will be always equal to Q. And the ratio Q by V is a constant and it is known as C. C is Q by V. Here the constant C is called the capacitance of a capacitor. C is called the capacitance of a capacitor. The capacitance C depends on the geometrical configuration, that is shape, size, separation, which medium we are using and all those things. So the value of C depends upon the shape, size of the conductors and the separation between the conductor and also the insulator. So that we will see later how to calculate the value of C using geometrical configuration. Now what is the SI unit of capacitance? SI unit of capacitance. The SI unit of capacitance is farad. F. It is Q by V. So 1 farad is equal to 1 coulomb per volt. I can write 1 farad as 1 coulomb per volt. Coulomb per volt. The symbol for capacitor is like this. So this represents the two conductors or two plates of a capacitor. This is the general symbol for a capacitance. Next is what is dielectric strength. Dielectric strength. The maximum electric field that a dielectric medium can withstand without breaks insulation is called strength. As I said, when we measure C, it also depends upon the insulating material or insulator which we are using between two conductors. So how much electric field this insulator can withstand without breaking, that will give you the strength of the field. We'll write the definition. Because if a breakdown occurs, then it loses its insulating property. So we should apply electric field in such a way that the property remains and the insulator will not break down. If it breaks down, it loses its insulating property. The maximum electric field that a dielectric medium can out of its property is called dielectric strength. For air, the dielectric strength is 3 into 10 to the power 6 volts per meter. For air, if you consider air as the dielectric medium, so for air, the dielectric strength is 3 into 10 to the power 6 volts per meter. Now, if there is a separation of 1 centimeter, if I have capacity, if the separation is meter, for 1 centimeter corresponds difference of, so this is 3 into 10 to the power 6 volts per meter. If I consider a separation between the conductors of the 1 centimeter, separation between the conductors order of 1 centimeter is volts per meter. So this corresponds to what is the potential difference between the conductor now. So potential difference will be (3 into 10 to the power 6 divided by 1 into 10 to the power minus 2, 3 into 10 to the power 4 volts. For a separation of 1 centimeter, the potential difference between the plates is around 3 into 10 to the power 4 volts. There exists a potential difference of 3 into 10 to the power 4 volts between the conductors. So there is definitely a limit to the amount of charge which a capacitor can store without leaking, because there is a limit for potential difference, because C is Q by V and we know that C is constant and it depends upon the geometrical configuration. Conductors, and because V has a charge, definitely has a limit. So definitely a limit to the amount of charge that can be stored on a capacitor without significant leaking. Right here, the limit to the amount of charge there's a limit to the amount of charge stored on a given capacitor. given with significant. There's always a limit on the value of resistor can reach. So we resistors the unit, and in general, the farad is. So the most common unit which we use as for a capacitor is, we say, like 1 microfarad, 1 picofarad, or nanofarad. So farad is a big unit. That is why the capacitors are expressed in microfarad, nanofarad, picofarad. Micro, we know 1 into 10 to the power minus 6. Nano is 1 into 10 to the power minus 9. Pico is 1 into 10 to the power minus 12. Let me write here. 1 farad, 1 into 10 to the power minus farad. 1 nanofarad, 1 into 10 to the power minus 9 farad. 1 picofarad into 10 to the power minus 12 farad. We may use 1 microfarad capacitor, microfarad, 100 micro. You can say it in nanofarad, farad. So this most used nanofarad, picofarad for a capacitor.